Okay, in this video I'm going to talk about a reminder of what we have mentioned before regarding the classification of diaphragms, and this is, we can find it under section 7.2.9.1 in ASCE 4117. Remember well that I'm talking about ASCE 41, not ASCE 7, okay? And as I said before, 41 means it is for evaluating of existing structure, performance and evaluating of existing structures. And this is a reminder of the previous video that I have talked before regarding the two main conditions. We have two main conditions in order to use the two-dimensional modeling, okay? And we mentioned that the first one is related to rigid diaphragms as defined under this section, and there is no torsional effects. And the second condition is related to the diaphragm or the building to have flexible diaphragm. Okay, so this is reminder of how we can classify diaphragms based on ASCE 41. So the flexible diaphragm is going to be defined as diaphragms shall be classified as flexible where the maximum horizontal deformation of the diaphragm along its length is more than twice the average story drift of the vertical seismic force resisting elements of the story immediately below the diaphragm. So we're talking about horizontal deformation along the length of the diaphragm, and it should be twice. If we have a look, next slide for example, this is giving us the two cases where that we have rigid diaphragm, as you can see here, and this is another case where that we have flexible diaphragms. The issue that we are talking about the deformation here. So if the deformation, look to the case of the flexible diaphragm, you're going to find that there are some deflection in the plane here. So if this deflection is going to be more than to the average drift of the entire floor, then we are talking about the case of flexible diaphragm. Okay, so that is what is meant here by twice the average story drift of the vertical seismic force resisting elements of the story immediately below. We're talking about the story below, okay, the diaphragm. Okay, on the other hand, if we are going to talk about the other case, which is rigid diaphragms, diaphragms shall be classified as rigid where the maximum lateral deformation of the diaphragm is less than half. We're talking here about 1/2 the average story drift of the vertical seismic force resisting elements of the story immediately below the diaphragm. Okay, so now we're talking about half. This is in case of rigid diaphragm. So if we go to next slide, here this is the case of rigid diaphragm. We're going to find that there is no, in the horizontal maximum deformation, almost nothing here. So this is almost nothing here. Compared to the flexible, you can find that it is flexible. Okay, so we are talking about horizontal deflection. Okay, so here it should be less than half the average story drift, And in the rigid diaphragms, you're going to find that there is concentration or shear in the connection to vertical elements, concentration of forces at the edges, because the rigid diaphragm is able to distribute the forces. So again, if we are going to have rigid diaphragm and there is no torsional effects, this means that this wall, for example, we can analyze it in a 2D, because we know that the forces are going to be distributed to this wall and to this wall accurately based on the rigidity of the diaphragm. Okay, so that's the issue related to the rigid diaphragm. Okay, let's go back here, and then the third category or the last classification of diaphragms is, we give it this name, stiff diaphragm. Diaphragms that are neither flexible nor rigid shall be classified as stiff. It is not falling into this category of rigid diaphragms nor flexible diaphragms. Then we're going to call it as stiff diaphragm. Okay, so that's the issue related to the classification of diaphragms under this section, which is section 7.2.9.1. As I said before, that whenever that we are going to determine whether or not the diaphragm is rigid, it is based on calculation, and we can go through this calculation or this condition that is given here, okay, whether it is flexible or rigid, okay. And if we want, we are going to have a separate video later on related to the calculation of the diaphragm rigidity in general. Okay, so I hope that you have understood the meaning of rigid and flexible diaphragm in terms of how the ASCE is classifying these diaphragms, and remember that I'm putting them in the related to the main issue that we are talking about, which is mathematical modeling and when to use two-dimensional mathematical modeling. We found that the two conditions are containing rigid or flexible, as we said, so this means that we need to understand the difference between the two. Okay, thank you for listening, and see you in the next video.